Hello and welcome. In front of you, there's a parabola. So parabola is a graph that we get whenever we graph a quadratic. Say somebody gives us the parabola and then says the parabola is for ax square plus bx plus c quadratic, and you have to identify the signs of each of the coefficients there. That means you have to figure out whether a is positive or negative, b is positive, negative, or c is positive or negative. Is there a way to figure that out? Looking at the parabola that we have in front of us, definitely there is a way. Let's look at a technique to find out the signs of coefficients of a quadratic given the graph. So you should have the graph in front of you to even make an attempt. We know any quadratic that is given, when we graph, it ends up giving us a parabola that opens upwards or a parabola that opens downwards. The one that is given opens upwards. Opening upwards and downwards has something to do with the sign of the leading coefficient. Leading coefficient is A. If the leading coefficient A is positive, then the parabola opens upwards. If the leading coefficient A is negative, then the parabola opens downwards. So in the given parabola, what should be A? It's a parabola opening upwards, so A must be positive. So let's write the answer here. A is positive. It is easy to figure this out just by looking at the way the parabola has opened up. It has opened upwards. So A is positive. Let's keep it aside. Next thing, let's focus on C, the constant, and then we'll come back to B in a while. To find out C, whether it is positive or negative, all we have to focus on is the place where it touches the y-axis. The parabola is touching the y-axis on the negative side, isn't it? Anything below the x-axis is going to be the negative side. And if the y-intercept is negative, C is negative. If the y-intercept is positive, C is positive. So now it is clear that the parabola is touching the y-axis on the negative side, and so we can conclude C to be negative. Okay, A and C are decided, but how do we get C to be negative? So it does not happen magically. There is a reason behind that. F of x equals ax square plus bx plus c. The y-intercept would have x value to be equal to 0. So I must plug in x is equal to 0. So this becomes a into 0 plus b into 0 plus c. C is the only thing that is not getting influenced now. Other two terms are becoming 0. So f of 0 is equal to c, which means the y-intercept would be 0, c. This tells us if the y-intercept is negative, c is negative. If c is negative, y-intercept is going to be negative. We can say it the other way around too. And then if c is positive, the y-intercept would have been on the positive side, but it's very clear that the y-intercept is negative, so c is negative, decided in this case. Moving our attention to b, coefficient of x. B is little tough or needs further analysis. It's not as straightforward as opening upwards, touching the y-axis at a particular point. So B actually is obtained by looking at the vertex. So vertex is the minimum most point on the parabola. It is when the parabola opens upwards, vertex is the minimum most point or the lowest most point of the parabola. If the parabola opens downwards, it would be the highest. So vertex would be here if it opens downwards. So vertex would have x coordinate as minus b over 2a. And then the y coordinate, of course, is the function value. So we are not that worried about the y coordinate. Let's focus on the x coordinate. Look at this parabola. The x coordinate of the vertex is on the negative side, isn't it? So we can conclude that minus b over 2a in this case is negative. if the vertex is in the third quadrant or it is in the second quadrant. Whenever the vertex is in the second quadrant or third quadrant or on the negative side of the x-axis, minus b by 2a, the x coordinate is going to be negative. So this coordinate is negative, minus 2 by b by 2a is negative. A in this case is positive. We already have identified A to be positive, isn't it? So what happens to the denominator? 2 into a positive value remains positive. So we can replace 2A with positive because we are only keen on the sign of B. So B over positive quantity in the denominator should give us a negative value overall, minus B over positive. What should be B? So that minus of B over positive should become negative. If B becomes negative, minus into minus would become positive. The overall value of minus B over 2A becomes negative. So if B is negative, minus B over 2A now becomes negative of negative number. Denominator is anyways positive. Overall, it would become positive. This is not what we are looking at. If B is positive, minus positive number over positive number, overall value turns out to be negative. So minus b over 2a becomes negative if b is positive in this case. So we can conclude b is a positive quantity. So that's how we identify the signs of the coefficients of the quadratic. A is straightforward. If the parabola opens upwards, A is positive, opens downwards, A is negative. C, depending on the y-intercept. If the y-intercept is on the positive side, C is positive. Y-intercept is on the negative side, C is negative. And when it comes to B, we have to focus on the vertex, x-coordinate of the vertex, which is nothing but minus B over 2A. So depending on A and B values, the vertex position is decided. So now in this case, since A is decided or we have determined A value to be positive, minus B over 2A becomes negative only if B is positive. So B's coefficient becomes positive. Let's look at one more case so that we understand this concept well. If I take one more parabola, let it open downwards this time. Something like this. Let's denote this parabola with f of x. Again, ax squared plus bx plus c. Any quadratic can be represented with ax squared plus bx plus c. To find out the sign of leading coefficient a, we have to check whether the parabola is opening upwards or downwards. Here in this case, the parabola is opening downwards. So a becomes a negative value. A must be negative. Then can we find out where exactly the parabola is touching the y-axis? The y-intercept of the parabola is not visible in the graph that is given, but we know a parabola when extended, we know how the parabola shapes up. So when you extend the parabola, it is for sure going to touch the y-axis on the negative side. Parabola obviously cannot go back and then touch the y-axis on the positive side. The only possibility when I go for further graphing of this parabola is going to be here. I mean, the y-intercept is going to be on the negative side. So that decides the sign of C, which here becomes negative. How about B in this case? To find out the sign of B, we have to go to the vertex. Vertex now is the maximum point of the parabola. Vertex would be minus B over 2A, comma, the function value at that very point. So we won't bother about the y coordinate. Let's look at the x coordinate there. X coordinate, let me use a different color for this. Minus B over 2A is on the positive side, isn't it? It's on the positive side of the x-axis. So this overall value should be equal to positive. A we have determined to be negative. So let's segregate this minus B's value we are trying to find out, put it under parenthesis. The denominator 2 into some negative value because a is negative in this case. So negative in the denominator, the negative that we have here, both of them get cancelled out. So overall we have b that would decide the sign of minus b over 2a. You know, b minus and minus are getting cancelled out. So b decides sign of minus b over 2a now. What should be the sign? It should be positive in this case. So if b is positive, it remains positive. If b becomes negative, overall sign becomes negative. So here b would have a positive sign. A is negative, C is negative, B is positive in this case. And this is how we find out the signs of the coefficients of a quadratic. The way the parabola opens up, the point where it touches the y-axis, and then based on the x coordinate of the vertex, we can decide the signs of A, B, and C.